In this video, I'm going to solve this organic chemistry synthesis problem where in the reactant molecule here we have a benzene with a bromine, and in the product here we have a benzene with an alcohol next to an OR group. So for synthesis type of problems, I like to see what are my similarities and differences between the reactant molecule and the product molecule. I see that the reactant molecule and the product molecule both have the benzene ring and this backbone of this alkyl chain here. The differences would be the functional groups attached to it, where we see in the product molecule, we have an alcohol and an ether group, whereas in the reactant molecule, we have an haloalkane, right? So now, once we have that, we can now do a strategy called retrosynthesis, going backwards, to figure out what reactions we need to convert this reactant molecule to this product molecule. We see that the OH and OR are adjacent to each other, meaning that this could have came from an epoxide opening, right? So if we go backwards here, this could have came from this epoxide between these two carbons right here, like that. And this oxygen of the epoxide here is going to be this oxygen of the alcohol, right? And this OR group here is going to be the nucleophile that attacks the epoxide at the less substituted position. And if we are attacking the less substituted position, we are going to be in basic conditions or negative charge conditions. So our nucleophile here is going to be, let's say, NaOCH3, and the solvent could be CH3OH, right? And that would be the first step. Second step would be acid workup, because when we kick open this epoxide, this oxygen of the epoxide will get a negative charge, which will get protonated by the second step to become neutral alcohol, right? But now we can go backwards to see where this epoxide could have came from. It could have came from MCPBA, from this alkene right here. And we see that this alkene right here is at this side of the haloalkane, which is the less substituted side. So if we want to form an alkene for the less substituted side, we want to do an E2 Hoffman elimination using a bulky base like LDA or tert-butoxide, right? So the first step here is E2 Hoffman elimination. Second step here is MCPBA. Third step here is going to be epoxide opening in basic conditions.